and good morning. So, welcome to week 5. This is the chapter 3 of our syllabus that is on stratified sampling. As I have mentioned earlier, we need to cover this chapter in week 5. In week 5 and week 6. So let's look at it. And if you have any question, you can stop me anytime during my presentation. Okay, this is the third chapter, stratified sampling. What is stratified sampling? Usually, we have supplementary information that can help us design our sample. For example, we would know before undertaking an income survey that men generally earn more than women, or people in Shah Alam pay more for housing than those who live in maybe Kota Baru, or rural residents shop for groceries less frequently compared to those who live in the urban areas. If the variable we are interested in takes on different mean values in different subpopulations, we may be able to obtain more precise estimates of population quantities by taking a stratified random sample. The word stratified comes from Latin words, and it means making layers or to make layers. We divide the population into H subpopulations called strata. And the strata do not overlap, and they constitute the whole population so that each sample unit belongs to exactly one stratum. For example, male and female. Male and female do not overlap with each other, right? So, but if we have population that consists of male and female, therefore we can have two strata. And why use stratified sampling? Why don't we use simple random sampling or systematic random sampling? First of all, we use stratified sampling because we want to be protected from the possibility of obtaining a really bad sample. When taking a simple random sample of size 100 from a population of 1,000 male and 1,000 female students, for example, we may come out with no or very few males possible, although such a sample is not likely to occur. Most people would not consider such a sample to be representative of the population and would worry that men and women might respond differently on the item of interest. In a stratified sample, one could take a simple random sample of 50 males and an independent simple random sampling of 50 females. This guarantees that the proportion of male in the sample is the same as the population, and the proportion of female is also the same as in the population. Secondly, we may want our data to have known precision for subgroups. These subgroups should be the strata, which then coincide with the domains of the study. Right? Sometimes we want to have the precision because generally in national level studies, for example, we want to have precision in the estimation of those who live in rural areas and those who live in the urban areas. So we want this data so that we can know which are the challenge, which problem that we can tackle on. The third one is we want to use stratified sampling so that our sample be more convenient to administer and may result in a lower cost of the survey. However, for example, different sampling approaches may be used for different strata. In a survey of business, a mail survey might be used for large firms, whereas a personal or telephone interview is used for small firms. In other surveys, different sampling methods may be needed in urban and rural areas. Using different method to collect the data can lower the cost of our survey. But usually in a national level studies, we will use the same data collection method for all the sample, because we want to have a consistent result. And this usually does not lower the cost, but increase the cost of the survey. And the last one, the fourth one, stratified sampling, if done correctly, will give more precise estimates for the whole population. Persons of different ages tend to have different blood pressures, for example, and those who live in rural and urban areas may have different economic status. So this can lower the variance of the estimates for the population for those who live in the two separated areas. Let's look at example 3.2. This is actually the same example as in previous chapter. However, this time we use stratified random sampling to choose the sample. In the previous chapter, in which we took an simple random sampling to estimate the average number of farm acres per county. In that example, we noted that even though we scrupulously generated a random sample, some areas were overrepresented and others not represented at all. Taking a stratified sample can provide some balance in the sample on the stratifying variable. In this example, as you can look here in the table, we have divided the areas into stratum, which are northeast, north central, south, west. We have 4 stratum. But if you use simple random sampling or systematic random sampling, some of the stratum here may be overrepresented, and some may not represented at all. For example, out of 3,078 a number of counties in all stratum, we have a large portion of counties at north, central, and south. So therefore, these 2 counties may be overrepresented because the proportion of these 2 stratum are higher, much higher compared to the other 2, northeast and west. So there is also a possibility that there is no sample in the northeast and west will be chosen in our sample if we use simple random sampling or systematic random sampling. But in this case, if we use stratified, we can divide it. We can divide the stratum, the counties into stratum, and then we can randomly select sample from each stratum. We can randomly select counties from each stratum. So by using this, we can have a representative, a proportional representative for all stratum. In this example, we take out about 10% of the counties in each stratum. So it is about 300 sample. Okay, it is about 300 sample. And if you look here, 200 and out of 220 counties, we randomly select 21. This is an approximation only. Approximation, 10% approximation of the sample selected from each county. For the North Central, 103 out of 1,054, South 135 out of 1,382, and for the West, 41 samples are randomly selected out of 422 counties. Yes.
Number of counties in sample tu, ada 10% of the number of counties in stratum
About 10%, yeah.
About 10%.
About 10%. It is not exactly 10%.
Oh, okay.
Okay, if it is exactly 10%, then you need to come up with maybe higher number of sample size. But in this case, we want to make it 300 only. We don't want to make it 308 samples. If you use exactly 10%, then you will have 308 samples here. Right? Do you have any other question? Right. There is. All right. Thank you for the response. So this is the summary statistics table for each region or each stratum. Since we have the sample for each region or stratum, then we can calculate the average and variance of each region. For 21 sample size, we have an average, the acre average of 97,000, 300,000 for North Central, 211,000 for South, and 662,000 for the West. So by doing this, you will be able to estimate the total population for each region. You can use this equation, T hat, or the estimate population total is equal to the N, here is the population size, times the Y bar. Y bar is the mean average. So as you look here at the T hat northeast, can you see my cursor here? Can you see my cursor?
Yep.
Yes, all right.
Yes.
All right, thank you. So if you look at our northeast here, we can calculate the estimated population total for northeast. The same goes to the north, central, south, and west, because we have the population size in earlier slide. Okay, this is the population size. Okay, and we also have the average size. Okay, estimated average size. So by doing this, you can calculate the estimated population total. Right. Now, you can also calculate the. So this is not to estimate the total population. The estimation of total population was represented in the previous slide. So you can also calculate the various estimation of the total of the northeast by using this equation. You already have all the values needed here. We have the population size, we have the sample size. We have also calculated the variance of the northeast. Okay, then you can calculate the estimated variance for the northeast. The same goes to the other region, north, central, south, and west. You can calculate the estimation of variance for each region. So complete the following tables. All right. Actually, you need to try to calculate these, the estimated total of farm acres for the other region. We have calculated earlier for the first one, that is the northeast. You can try to calculate for the north, central, south, and west. And if you calculated all, okay, if you calculated the estimated total of farm acres for north, central, south, and west, and also the estimated variance of total for north, central, south, and west, you will come up with this table. You just need to use the same formula that I have shown to you earlier. This one, these two formula. This is to calculate the estimated variance. Okay, you can use this formula and you can complete the table. All right, so far, do you have any question?
No, doctor.
Thank you.
No,
Thank you very much for your response. Right, so since we can calculate the estimated variance for all samples, for all regions, okay, in the stratified random sampling and also simple random sampling. The estimated variance here from the simple random sampling, here you can refer to our previous chapter. We have discussed about this. I have also shown to you how to calculate the estimated variance from the simple random samples. And we got this value before, 3.3837. And for this one, for the estimated variance from stratified, we get 2.5419. Okay, 2.5419. You can just cancel off these two because it is the same. Then in this example, you can look that the estimated variance from stratified is much lower compared to the estimated variance from the simple random sampling. It is much lower. And if we calculate the design effect by using this formula, you will get the design effect value of 0.75. 0.75. This means that stratified sample of size 300, okay, will give the same variance as an this means that the stratified sample of size 225 would give the same variance as a simple random sample of size 300. If you look here, 0.75 times 300 is equal to 225. It means that if you randomly select 225 sample out of by using stratified sampling technique, you will get this variance. You will get this variance, the same variance, if we randomly select 225 sample using stratified sampling technique. But in this example, we randomly select 300. That is why our estimated variance from stratified is much lower compared to the estimated variance from the simple random sampling. Are you clear?
Yes, Doctor.
Yes, Doctor.
Thank you. Thank you for your response. Do you have any other question before I proceed to the next slide? No? All right. Yes? So this is 2.5419, yeah? This is 2.5419. This is just a total of all of this value. You will get the total of estimated variance of total for stratified is equal to 2.5419. All right. Now let's compare the simple random sampling and stratified random sampling. Let's further compare it. Now, by using the same sample size, you will get the estimated population total of simple random sampling is 916,000. But for the stratified sampling, it is 909,000. And for the standard error, by using the simple random sampling, it is around 58,000. Sorry, 58,000 or million here. I need to check this. Give me a second. It is, I think this one is 58. Yeah, maybe it is 58 million as compared to stratified sampling 16,000 only. There is a huge difference in the standard error here. It means that in our case here, the stratified sampling technique gives us much lower standard error compared to the simple random sampling. So if you have enough cost, or you have enough, you have sufficient labor, you have much time to conduct a survey, it is highly recommended to use stratified sampling technique as compared to the simple random sampling. Okay, for this example, stratified sampling ensures that each region of the United States is represented in the sample and produces an estimate with smaller standard error than and simple random sampling with the same number of observation. Even though we have the same number of observation here, the estimation error, the difference in the standard error is huge. So we can conclude in this example that stratified sampling technique is much better compared to the simple random sampling. And let's move to the next subtopic, that is on the theory of stratified sampling. Theory of stratified sampling. All right, so we divide the population of the N here, okay, we divide the population of N sampling units into H layers or strata with NH sampling units in stratum H. In previous example, we have 4 stratum, so we can know what is the sample size for each strata, right? So these are our population size for each strata. Which one? This one. This is the NH. NH. Okay, this is our population size for each strata. Right, this one. For stratified sampling to work, we must know the values of N1, N2 until NH. In previous example, we already know the population size of what are they? Northeast, North Central, South, and West. We already know this value in our previous example. And the total population, it should be the summation of the population size for each stratum, right? And in stratified sampling, we apply a simple random sampling for each stratum, in which all observations are randomly selected, and all elements in the population or all elements in the stratum have equal chance of being selected as the sample for the study. Okay, that is why we have discussed earlier that simple random sampling is the foundation or the most basic sampling technique. Let's look at this diagram. Okay, so let's say we have a total population, a population size of, let's say in Malaysia, we have 32.5 million people in Malaysia. Then we can divide the population into three groups. For example, we have Bumiputra. This is just an example, and Chinese and Indian. So we know that Bumiputra is around 68%. For example, this one is around 20% or 25%, 25%, 68, 25. And we have, for Indian, how many percent? For Indian, 7%, right? 7%. So 68% out of 3.5 million is equal to? Guys, 22.1 million. 22.1 million. This is our N1. N1. Okay, and our N2, 25% out of 32.5 is equal to 8.125. 8.125 million. This is our N2. And 7% out of 32.5 million is 2.275 million. This is our N3. This is our N3. And out of these, the population size of N1, N2, and N3, we can randomly select the sample for each stratum. We can randomly select the sample from Bumiputra, Chinese, and Indian by using the simple random sampling. Simple random sampling. So let's say you would like to collect 10,000. Okay, 10,000 sample. So this 10,000 sample must consist of 68% Bumiputra, 8 point, sorry, it is not 8, it is 25% Chinese and 7% Indian. So we will have 6,800 Bumiputra, we will have 2,500 Chinese, and we will have 700 Indian as our sample. Altogether, you will get a total of 10,000 sample. Okay, and this is our N, the total sample, by using the stratified sampling technique. Do you have any questions so far? No question. All right. If there is no question, let's move to the next slide. The notation of stratified sampling. All right, the notation for stratified sampling. All right, same as in the simple random sampling, you can calculate the population total. You can calculate the population mean in the of estimation. You can estimate the population total and population mean. But in stratified sampling technique, you can go further, because in stratified sampling technique, you can estimate actually the population total in each stratum, because we have the value for each stratum. We have the value of the N, the population size of each stratum, and you can calculate also the variance of each stratum. You can also have the standard error of each stratum. Then you can also have the mean for each stratum. Then you can calculate the population total. Okay, so you can use this formula to calculate the population total in each stratum, where YHJ is the value of elements in stratum H. Stratum H. Okay, let's say we have 4 stratum. We have northeast, north central, south, and west. So you can calculate the population total in each individual stratum. And by using this, from this one, you can calculate the population total of the population. The estimate, sorry, you can calculate the population total by summing up all the estimated population total in each stratum. If you look here, it is an extension of the first one. The second one is an extension of the first one, right? And you can also calculate the population mean in stratum H, in individual stratum. Okay, you can calculate the population mean for northeast, north central, south, and west. And number 4 here, you can calculate the overall population mean. This is an extension of this one, of number 3. Number 4 is an extension of number 3. Okay, that is, you can sum up the value of the population total over n, over the population size, and then you can come out with the overall population mean. The same goes to the variance. You can calculate the variance of each stratum by using the formula. Don't worry about the formula because it will be given in your final assessment. But what you need to know is that you need to know what are the notations here. What is YHJ, what is TH, what is TH, and what is Y bar HU, right? So what is YHJ here? YHJ is the Y value for each element in stratum H. For example, we have, I think we can look at the example in the next slide. Okay. Next slide. I think it is a bit later. We will look at the example. All right. This is the same. Now, for this one, suppose we only sample the H stratum. Okay. Suppose we only sample the H stratum. In effect, we have a population of NH. In previous slide, for example, we only sample the Bumiputra. So we have, we know that out of 32.5 million, the sample of Bumiputra, the population total, it is not the population total, the population size of Bumiputra is 20, let's look at 22.1 million. 22.1 million is the population size of Bumiputra, right? And out of these 22.1 million Bumiputra, we randomly select the population size of Bumiputra. We randomly select, what was it? 6,800. 6,800 Bumiputra. Okay, so you already have these two values. The population size of Bumiputra, this one, and the sample size of Bumiputra. Then we would estimate the Y bar HU by YH. Okay, what is Y bar HU here? This is the Y bar. This is the mean of Bumiputra. We can estimate the mean of Bumiputra by using the Y bar H. What is Y bar H? This is the estimated mean of Bumiputra. And we can also estimate the population total of Bumiputra by using the estimated population total of Bumiputra. Okay, let's look at it. For example, from the Bumiputra, let's say we have calculated the mean. Okay, the mean salary of 6,800 Bumiputra. Let's say the mean. Okay, the mean salary of 6,800 Bumiputra is equal to 4,000. 4,000. And this is just an example. So we can say that the mean salary of all Bumiputra in Malaysia is 4,000. That is why it is said here that we can estimate the Y by HU. HU here, U here means the overall population. Okay, we can estimate it by using the sample that we have randomly select here, 6,800. And for the TH here, we can estimate the TH. What is TH? TH is the population total. Population total. It is the actual population total. We can estimate it by using the estimated population total. Estimated population total here is based on the 6,800 sample, right? So let's say we know that our population total here is we have 22.1 million here, 22.1 million times the Y bar H. What is Y bar H? That is the Y bar of Bumiputra, the mean salary of the Bumiputra times 4,000. So we can say that the total population of salary of Bumiputra is equal to how many? How many? Is equal to 8.84 times 10 to the power of 10. So I don't know how much ringgit Malaysia this is. This is the total population total, or the total salary of 22.1 million people in 22.1 million Bumiputra in Malaysia. So this is the RM lah. RM. This is a weighted average, all right? So we have discussed this one, and we have also discussed this one. Okay. Any question? Any questions so far?
No, Doctor.
No question, yeah? All right. No, actually we have not discussed this one, yeah? Now, this is only for the Bumiputra. This is only for Bumiputra. We also have two other major populations, okay? Major subpopulations in Malaysia. We have Chinese and we have Indian. Once you have calculated the value of all Bumiputra, Chinese and Indian, only then you can calculate the estimated total population for all Malaysian. You can just do it by using this formula. We already have the value for all. For example, here estimated population total we have for Bumiputra is 8.84, maybe for Chinese 6 point something, and Indian is maybe 3 point something. Then you can calculate it all, you can sum it all, and you can get the total population, estimated population total by using the stratified random sampling. STR here indicates the stratified random sampling. The same goes to this one, the mean total, the mean population of if using stratified sampling technique. Right. Now, yes.
Why it is in RM?
Yeah.
Should stand for?
Sorry?
Why it is in RM?
Because our Y here All right. Our Y here is the RM. This is the mean salary.
Oh, mean salary. Okay.
This is the mean salary of Bumiputra. You can also calculate the mean salary of Chinese and Indian, and then you can calculate this one lah, the estimated population total. This is for one variable. In our data, we have many variables, right? But this example, we discuss on one variable. For example, salary. You can also use other variables, but you need to calculate it differently. If you want to use maybe perception, or maybe you want to use the other than salary, maybe you want to use something like the what is it? Maybe height or weight, something like that.
Okay, Doctor. Thank you.
All right. Any other question?
No, Doctor.
You sure? So far so good, yeah?
Yeah, so far so good.
All right. Now, thank you for your response. Now let's move to the properties of these estimators, which follow directly from the properties of simple random sampling estimators. First of all, stratified random sampling, same as the simple random sampling, it is an unbiased estimator. Why? Because we can say that since we use simple random sampling when selecting sample for each stratum, we can say that it is an unbiased sampling technique, because from there you can also calculate the Y by U, or the mean salary of all Malaysian, and the population total of all Malaysian by using the Y bar stratified and T hat stratified. The mean salary by using stratified sampling technique, it is to be exact, it is the estimated mean salary by using stratified random sampling. And you can also calculate the estimated population total by using the stratified sampling technique. Okay. If Y by U here, it stands for the mean salary of the population. This is the estimated mean salary by using stratified random sampling. And this so you can use it. It's consequently we can prove that it is unbiased by using this formula. Okay, it is proven that it is unbiased estimation. And the second one is variance of the estimators. Since we are sampling independently from the strata, and we know that the variance of the estimated total population for each stratum, same as in the simple random sampling theory, the properties are expected, the properties of expected value in section A.2 in previous chapter imply this one. But this one is for the stratified random sampling. You just extend it from the simple random sampling. And the standard error of an estimator is the square root of the estimated variance. Okay, you square root the estimated variance, then you can get the square root, the standard error of the estimator. And the third one is confidence intervals for stratified sample. Since you can calculate the standard error in previous one, in this here, you can calculate the standard error, then you can also calculate the confidence interval for stratified sample by using this formula. Previously, we have calculated this one. We can calculate the estimated mean by using stratified random sampling, and you can calculate the standard error, And you can also use the Z alpha over 2 here, refer to the Z table to get, it depends on the how much confidence you want to come up with your confidence interval. Okay, let's say you want to come up with a 95% confidence interval. Let's say 95% confidence interval, then our alpha is equal to 0.05, then alpha over 2 is 0.025. Then Z alpha over 2 is equal to, sorry, Z 0.025 is equal to, refer to the table, Z table. Okay, anyone have problem reading the Z table? Anyone? Please make sure that you recall what you have learned during your degree, yeah? How to read the Z table here. Anyone can help me with this value?
1.96.
Sorry?
1.96.
1.96, yeah. 1.96, correct. All right. So example 3.3, Smith and Cook use stratified random sampling to estimate the size of the Nelchina herd of Alaska caribou in February of 1962. In January and early February, several sampling techniques were field tested. The field tested told the investigators that several of the proposed sampling units, such as equalifying time sampling units, were difficult to implement in practice, and that an equal area sampling unit of 4 square miles would work well for the survey. The biologists used preliminary estimates of caribou densities to divide the area of interest into 6 strata. Each stratum was divided into a grid of 4 square miles sample unit. Stratum A, for example, contain, yeah, this is Stratum A, for example, contain a population total or population size of 400 sampling units, and 98 samples were selected in the survey, and the following data were reported. Because the area is too big, therefore the researcher decided to divide the area into 6 stratum, because it will be easier for them to conduct the study. So after divide the area into 6 stratum, they come up with this value. Okay. Where is mine? Oh. Okay. Let's say, okay, from here, I believe you all have the slide with you, right? So what is the population total here? What is this? 400 is the what value here? This is the
Population size.
yes, the population size of stratum A. But population of what? Population of
Each group.
This is the population of Nelchina herd. I'm not sure what is it. Nelchina herd. Maybe I think it is it's a bird species, Nelchina herd. Okay. And out of the 400 Nelchina herd in stratum A, they randomly select 98 Nelchina herd. The same goes to stratum B, C, D, E, and F. So in the same example, what is the y bar h here? What is the y bar h? It is the example, it is the
mean.
Equal flying time. Okay, this is the flying time. We can say that y here is the flying time for this Nelchina herd, and the flying time for herd in stratum B, C, D, E, and F. So they have different flying time. So that is why in stratified random sampling, you can get a better estimation. Because if you look here, if you use simple random sampling, you won't be able to know the flying time of Nelchina herd at each stratum. So you may only come out with a mean that cannot represent maybe the Nelchina herd at stratum A. Because if you come up with a mean, you can only get the mean of all. If you look here, the flying time is really differ. Okay, it is a big different flying time of Nelchina herd at stratum A compared to stratum E, for example. It is almost 10 times dia punya flying time tu lebih lama, 10 kali ganda Nelchina herd at stratum E compared to stratum A. That is why, if me, I would prefer using stratified random sampling, because we can look at this. We can look at this depth of insight. We can get this insight to maybe help us in the decision making or to make estimation. Right. So by using this table, the information in this table, you can also calculate the estimated population total for each stratum. And what is this? What is this? What is this? What is column G? Anyone? You can also calculate the variance. Okay, if you look back here, the variance, the estimated variance of the mean flying time by using stratified sampling technique. So this is the estimated mean flying time it is not estimated mean flying time, right? It is the estimated variance of mean, estimated variance of mean flying time by using stratified random sampling. Okay, then if you calculate for each one by using the formula that I have shown you, you will get this value. Okay, you can come up with this value. The estimated population total for stratum A is 9640, B 768, and so on. And then from there, you can also calculate the estimated variance of mean of flying time by using stratified random sampling, and then you can calculate the standard error here. Ini kan soalan yang saya biasa keluarkan jugalah, because at the end of the question, I will ask you to calculate the confidence interval. So kalau awak silap buat calculation dekat sini, awak akan dekat sini awak akan dapat the estimated variance of mean. Okay, you akan dapat lain. salah satu kat sini you akan dapat estimated variance of mean. By using stratified, you akan dapat salah and then you will get wrong answer here. Standard error. Then it will lead you to have a wrong confidence interval because look here, mana dia? Alright, here this one. Confidence interval, you need to use this value, right? So please make sure that you can you double check your answer before you proceed with the confidence interval calculation. Okay, then once we already calculated the standard error of the mean flying time of Nelchina head by using stratified random sampling, then you can calculate the confidence interval here by using this formula, right? So this is at, if you look here, 1.96. So we can say that at this approximation is at 95% confidence interval. Any questions so far?
So far okay, Doktor.
No, Doktor.
Okay, yeah. Are you sure? Okay. I hope you are clear, especially on the notations, because notation dia boleh jadi quite confusing lah sebab banyak sangat kan notation. Okay, let's recap. Before I move further, let's recap. Right, which one? Alright, this one lah. Okay, kita recap balik apa dia setiap notation. Okay, this time I will explain in bahasa Melayu lah. Okay, sebab kita nak recap kan. Okay, now TH is the population. TH ni kena bahasa Melayu ialah population total. Kalau menggunakan simple random sampling, kita tak ada H tu. Sebab H tu, H kecil ni, H kecil ni ialah represent apa? This one? Represent?
Number of stratum.
Bukan number of stratum. Represent individual stratum. Kalau awak ada 4 stratum, contohnya in our earlier example, kita ada apa tadi, north east, north central, south and west. Awak ada 4 stratum. Maksudnya awak akan ada T1, T2, T3, T4. Itu maksud H ni. H ni boleh jadi 1, 2 or 3 or 4. Salah satu saja. Sebab kita nak calculate untuk setiap stratum. Okay, clear tak?
Clear, Doktor.
Alright, thank you for your response. Jadi kita nak calculate population total untuk setiap stratum. Dan kalau tengok kat ni T ni kan, yang T yang kedua ni pula dia tak ada. Dia tak ada H. Sebab apa? Sebab T ni population total untuk population. Sebab kita sekarang kita stratify. Bila kita stratify, okay, saya nak expand this. Kalau dalam simple random sampling awak akan jumpa T saja. Kenapa? Sebab dia tak pecah. Dia tak pecah kepada strata. Dia tak pecah kepada north east, north central, south and west. Tapi dalam stratified dia pecah. Bila dia pecah, kita nak kena dapatkan balik T ni kan. Katalah tadi kita bincang pasal salary. Kita nak tahu example total salary rakyat Malaysia ni berapa. Jadi kita pun buatlah T1 plus T2 T2 plus T3 plus T4. Ni kalau yang 4 ni lah. Tapi tadi kalau tak ada kata kita ada Bumiputera, Chinese and Indian saja, tak adalah yang 4 ni. Itu kita akan dapat balik T tu. Okey, kemudian yang ketiga, Yang ketiga ni, okay, ini ialah the Y bar HU. Apa Y bar HU? Y bar HU. The mean salary, Y kita kan salary, kan? Betul? Salary of strata HU. U ni apa? U apa? Apa dia? Cepat, cepat.
Overall population.
Hampir tepat. Overall population untuk strata H sahaja. Contohnya, bila Y bar HU ni maksudnya awak akan ada, saya buat lagi satu slide. Alright. Y bar HU. Ingat, kita ada H kat sini. Bila ada H maksudnya katalah Y kita is equal to the salary. Alright. So kita ada H. Maksudnya ada strata. Maksudnya Y bar untuk Malay. Malay bukan Malay. Bumi Putra. Kita akan ada Y bar untuk Chinese. And kita akan ada Y bar untuk Indian. U ni pula apa? U ni pula untuk overall. Overall maksudnya kalau Malay tadi kita ada berapa million? 22.1 million kan? Bukan. Overall ni maksudnya untuk kesemua Bumi Putra 22.1 million. Untuk Chinese pula berapa keseluruhan? Untuk Indian pula berapa? Jadi kita boleh calculate lah ada mean salary untuk keseluruhan Bumi Putra, untuk keseluruhan Chinese dan keseluruhan Indian by using the Y bar Bumi Putra sahaja. Yang ni bila tak ada U maksudnya untuk sampel. Kita boleh estimate by using sample. Right, kalau ada U maksudnya untuk overall. Kita estimate menggunakan sample. Okay, katalah kat sini ini untuk sekejap, saya buat macam ni. Bumi Putra, Chinese, Indian. Kita kan randomly select kan. So, bila kita randomly select, kita akan dapat kecil sikit lah. Bumi Putra, Chinese, Indian. So, by using the mean salary yang kumpulan kecil-kecil ni, saya buat macam ni. Kita calculate the mean salary yang kecil-kecil ni, kita dapatlah nilai ini. Kita dapatlah nilai mean salary. Kemudian kita estimate, kita cakap bolehlah yang contohnya tadi Bumi Putra, kita cakap based on our sample, kita dapat the mean salary of Bumi Putra is equal to 4,000. So this 4,000 can also represent the population. Sebab kita randomly select berapa tadi? 6,800 sampel Bumi Putra daripada 22.1 juta penduduk Bumi Putra. Clear tak? Okay?
Ya, doktor.
Okay, alhamdulillah. Alright. Itu yang ini. Okay, ataupun kalau awak tengok formula ni, kan, dia samalah sebenarnya. Summation of YHJ ni pula, macam mana saya nak tunjuk? Saya tunjuk kat sini balik Summation, kan kita tengok formula kita, Y bar HU. Y bar HU is equal to summation of Y HJ over NH, right? So untuk summation of YHJ ni kan kita boleh dapat dia punya Y bumi putra tambah Y Chinese tambah Y Indian over NH. So boleh dapatlah dia punya mean salary. Ataupun kalau awak nak senang faham YHJ ni, Y kat sini untuk keseluruhan bumi putra keseluruhan bumi putra. Kat sini ialah Y untuk keseluruhan Chinese dan Y untuk keseluruhan Indian. Yang YHJ kat sini ialah sebenarnya dia kira macam simple random sampling. Kita ada 32.5 kan million people tadi, bumi putra campur Chinese campur Indian for example. Dan maksudnya YHJ ni orang yang pertama salary katalah 2,800 tambahlah sampai orang yang ke 32.5 juta. Tapi ni salah lah saya bagi example sebab 32.5 juta penduduk ni bukan semuanya bekerja kan. Mungkin ada proportion yang mungkin kita ambil benda yang bukan salary ke kan, nak tahu keseluruhan penduduk 32.5 juta tu berkenaan dengan apa. Tapi kalau awak nak buat salary, awak kena tengok balik apakah umur bekerja rakyat Malaysia. Saya rasa kalau yang orang bekerja dalam Malaysia ikut definasinya umur 15 hingga 60 tahun. Jadi awak kena check balik dengan Department of Statistics berapakah populasi orang yang bekerja 15 hingga 60 tahun ni, berapa orang? Mungkin berapa persen lupalah saya berapa persen. Katalah for example 60%. For example 60% darablah 32.5 juta, barulah awak dapat nilai sebenar berapa population awak. Population orang yang bekerja. Ini example sajalah. Okay, example. Maksudnya kalau YHJ ni, kalau kita punya population of interest ialah 32.5 juta, maksudnya kita kena dapatkan the Y value of all 32.5 million people. Tapi kita buat estimation menggunakan sampel je lah. Okay. Alright. Dah ke situ ke sini dah arrow kan. Okay, samalah untuk yang variance yang ini, population ni pun sama. Awak boleh guna this formula. Okay, ini sebenarnya formula yang sama je yang awak guna sebelum ni untuk calculate the variance. Betul tak? Perasan tak? Formula ni sama je untuk calculate variance sebelum ni. Cuma dia ada YHJ dengan YHU. Sebab apa? Sebab kita dah pecah kepada strata. Boleh? Okay kan?
Boleh.
Alright, thank you. So it's 9:13 already. I think we can have a break, a 5-minute break. Okay. Nanti kita sambung balik. Slide berapa tadi? Oh, this one. Stratified sampling for proportion. We will resume at 9:20. Sekarang 9:14. 9:20 kita sambung ya. Sikit lagi. We have 5 to 6 slides left. Hello, are you still there?
Yes, Doctor.
Yes, Doctor.
Thank you, thank you. Okay, kita continue sikit lagi ya. Now we had, let's move to the stratified sampling for proportions. Okay, stratified sampling for proportion. As we observed earlier in chapter 2, actually, in chapter 2, a proportion is a mean of a variable that takes on values 0 and 1. To make inferences about proportion, we simply use the result in 3.1 unto 3.5. So this is we can use approximation. We can use approximation. Let's say you don't have the variance. Sorry, the variance of each stratum. Let's say in your final assessment, I don't give the variance of the of each population, subpopulation, or for each strata, but I give you the proportion value. Okay, so you can use this formula, okay, to estimate or to approximate the variance of the strata. Okay, this is actually, if you remember, NPQ. Okay, but this is just actually the NPQ over n minus 1. But you need to calculate the NPQ over n minus 1 for each of the stratum, for each stratum. Therefore, by using this, let's say, for example, we have a proportion value. For example, the female members in a population, let's say 40% of the population, sorry, let's say saya bagi contoh yang berkaitan dengan tadi, kita ada Bumiputra, Chinese and Indian. So in your population of interest, we know that the proportion of female is for Bumiputra, let's say 49%, for Chinese 47%, and for Indian 52%. So you can use this value as your P value. Okay, this is your P value. Okay, you need to convert this 49%, you need to convert it to 0.49 lah. So 0.49 times 0.51 over n minus 1. What is our n before? Our n for Bumiputra? 6,800, right? So 6,799 n minus 1. So you can use this value. Oops, n. What is our n? Our n is 6,800 times this one. Okay, something like that. Then you can use this to estimate or to approximate the variance. Faham? All right, thank you for your response. Then once you get the variance value here, then you can also calculate the estimated proportion by using stratified sampling technique. Okay, you can use this formula lah to approximate the proportion value. Okay, same goes to the estimation of variance of the proportion, of the estimated proportion. Kita just tukar dekat belakang ni saja, sama macam yang sebelum ni, just tukar kepada PQ over n minus 1. Okay, just tukar. Kalau sebelum ni kita guna, sekejap. Sekejap ya. Kalau kita tulis balik yang sebelum ni, 1 minus NH N square H over mana dia? Kalau sebelum ni kita guna yang ni kan, but this time if you use proportion, use this formula. Alright, then untuk ini sama je lah, just tukar kepada proportion. Basically it is just the same, just tukar kepada proportion sahaja. Right. Now let's look at this exercise. Okay, consider the hypothetical population below. Consider the stratification, N1 is equal to N2 is equal to 4. Consider the stratified design in which the sample for N1 and is equal to the sample of N2 is equal to 2. Okay, sekarang ni write out all possible simple random samplings of size 2 from stratum 1. Find the probability of each sample. Do the same for stratum 2. Okay, kalau perasan kat sini ada dua stratum. Stratum 1 and stratum 2. Write out all possible simple random sampling of size 2 from stratum 1. How do you do this? You can just do like this. What is our N value? 4. The population for stratum 1 is equal to 4. 4 C2. Same, right? So you will get the value is equal to 6. Correct? The same goes to the second one. For C2 also you will get 6 different sample. Look at here. For C2 untuk sample number 1, okay, you will get 6 different samples. Same goes to the sample number 2. For C2 also you will get 6 possible samples. Now for each possible sample, write down all possible samples. You have S1 1, okay, S1 2, S1 3, 1 4, 1 5, 1 6. Okay, now I would like to explain about what is S11. This one here is representing the stratum number 1. Stratum number 1. And the second one here represents the possible sample number 1. Possible sample. So since we have 6 possible samples, as you can see here, the value here, it changes from 1 to 2 to 3, 4, 5, and 6 because we have 6 different samples. But the number 1 here at the front here, it remains because it represents the stratum number 1. The same goes to the second one lah. Okay, second one, the first 2 here, okay, represent the stratum number 2. And the second value here represents the possible sample for stratum number 2. Possible sample number 1, possible sample number 2, 3, 4, 5, and 6. So far, are you clear?
Yes, Doctor.
Right, thank you for your response. Now let's look at the table back. Now, we have 6 possible samples. Then if you list out the 6 possible sample, it will be for sample number 1 is 1 and 2. Yang ni awak kena ingat balik apa yang Haris cerita in our last class when we discussed our the assignment. S11 is 1 and 2. 1 and 2, then 1 and 3, S12, 1 and 3, sampailah you dapat S16. Yang last kali, it will be 3 and 8. That is why here, awak dapat 1 and 2, 1 and 3, 1 and 8, 2 and 3 to 8, and last kali 3 and 8. Okay, sampai situ sahaja. But why? Because we want to list down the possible sample for stratum number 1 only. Kat sini dah stratum number 2. Tak ambil kira dah. Okay, stratum number 1 only. This one only. This 4. This is stratum 1. This is stratum 2. Repeat the same for stratum number 2. Okay, so since once you repeat, you will get this value lah. 4, 5, 4, 6, 4, 7, 5, 6, 5, 7, and 6, 7. Now, remember that we have kita ada dia punya probability. Okay, remember we have equal probability this time. Okay, equal probability for each stratum. So since we have 6 possible sample for both stratum, then we have the probability value is equal to 1/6. 1/6, yeah. Semua 1/6 because we have 6 possible samples. Okay, now we already have list down the all possible sample for stratum number 1 and stratum number 2. Now let's move to the second question. Using your work in A, find the sampling distribution of the estimated population total by using stratified sampling technique. Now, to come up with the sampling distribution, you just repeat the same process as in the simple random sampling. But this time, you do it separately for stratum number 1 and stratum number 2. In simple random sampling, we do it in one shot. We didn't divide the population into categories, or we did divide the population into stratum. But this time, you need to do it separately for stratum number 1 and stratum number 2. Repeat the same process, but for different stratum. Okay, you need to calculate the estimated population total for sample number 1 until sample number 6 for both stratum. For both stratum. This is stratum number 1. This is stratum number 2. From here, to calculate the estimated population total of by using the stratified sampling technique, it is actually the combination of strata 1 and strata 2. Stratum 1 and stratum 2. Thus, we will have 36 different combinations. Macam mana nak keluarkan dengan 36 different combination? Anyone? Anyone who can help me on how you can come up with the 36 different combinations? Anyone?
Six times 6.
Correct. It is 6 times 6. What is 6 here? This is possible sample of stratum number 1. And the second one here is the possible sample of stratum number 2. 6 times 6. So you will have something like this. Let's say stratum number 1, 2, 3, 4, 5, and 6. Stratum number 2. 1, 2, 3, 4, 5, and 6. So in here you will have 36 combinations, right? 36 combination. And to come up with a value for the 36 combination in here, you need to calculate each one, each individual combination. You need to calculate 36 times. This is in theory, but in real world, we will just use, we won't do this, right? This is a theory to prove it. Now, remember that you have 36 combination that you need to calculate each one. That is why here you will have the probability is equal to over 36. The denominator is over 36 because you need to calculate the combination of possible sample for stratum number 1 and stratum number 2. Okay, stratum number 1 and stratum number 2. You need to calculate it 36 times. And once you have calculated all the combination 36 times, then you will come out that with the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different K value. Okay, 9 different K value. Okay, saya nak tunjuk contoh. Katalah kita tengok salah satu out of 36. Yang ni yang ni yang pertama, yang ni yang kedua, yang ni yang ke-36. Right. Kita ambil yang first one. First one is the combination of stratum number 1 here is the combination of the first possible sample in stratum number 1 and first possible sample in stratum number 2. Tengok balik ya. Stratum number 1 and stratum number 2. First possible sample. First possible sample. Right? Now, kita tengok balik ke sini. First possible sample untuk stratum number 1 is 1, 2. First possible sample untuk stratum number 2 is 4, 5. Now, look at the value here. 1, 2, and 4, 5. Okay. 1, 2, and 4, 5. The value of Y is 1, 2, and 4, 7. 1, 2, and 4, 7. Tengok ya. Right. The Y value is for stratum 1 first possible sample is 1 and 2 for 1, 1, and this one is 2, 1 is 4, 7. But you need to calculate what? You need to calculate the T value. The T, estimated T value. Kita dah calculate tadi kat sini. Estimated T value number 1, 1 and 2, 1. Alright. Sekejap 1, 1 and kita tak klik yang 2, 1. Okay, 1, 1 is equal to 6. Oh, this one here is 2, 1. 2, 1 is 22. So that is why this one, sorry, saya salah, sorry ya. Saya tersalah tengok. Bukan ni. Yang ni number 1, number 2, number 3, number 4, 5, number 6. This is number 7, number 8, 9, 10, 11 and 12. Yang ni nombor 36, 35, 34, 33, 32, 31. Okay? Yang kat tengah-tengah ni saya tak buat sebab banyak sangat. Okay, so now kita nak calculate yang first possible sample in stratum number 1 and first possible sample in stratum number 2. It's just the T11 plus T21 that is equal to 28. Yang ni lah T11 6 plus T21 22 that is equal to 6 plus 22 is equal to 28. So this is the value here, 28. And if you repeat the same process 36 times, you will get 28 one time. You will get 32 one time also. This one, which one is 32? Not here. Maybe it is not calculated. This one is 32. Tak nampak kan? Oops. This one, 32. Satu kali saja you akan dapat. And 34, you will get 6 times. 1, 2, 3. This one 1, 2, 3, 4, 5. Ada satu lagi mungkin dekat tengah-tengah ni kot. Okay, you will get 6 times and the same process repeat until you dapat 52 5 times. Look at here, 52, 1, 2, 3, 4, 5. Then you can come up with the probability distribution. Any question? Sampling distribution, sorry. Any question here?
So far tak ada, doktor.
Faham ke? Saya risau je.
Dia
Faham
faham cuma kena buat example lagi.
Okay, alright. Ya, cuma saya nak highlight kat sini yang sini ini ialah macam table tadi dah. Ini table yang ini. Table ini sebenarnya kat sini. Cuma kat tengah-tengah ni saya tak buatlah calculation sebab banyak sangat kan. Alright, so same process. Once you already have the probability value, you already have the k value, then you can calculate the here the mean and variance of the sampling distribution. You can calculate lah the mean and variance of the sampling distribution. This is the mean only of the sampling distribution, and you can try to calculate the variance of the sampling distribution. All right, so okay, I think that's all for today for the stratified random sampling. Before we go, we discuss on the sample size calculation. Do you have any last question? No question?
No, doktor.
All right. Okay, thank you for your response. Now let's look at the sample size calculation. Sekejap ya.